One of our applications of angles and trig is in surveying and navigation. So if you are navigating particularly a boat or an airplane, you don't have roads to follow. And so we need to have directions so you know which way to go. And just saying north, south, east, or west isn't good enough because that's only 4 directions in the whole wide sky. So we use angles to explain which direction you should be going. So in ships, we use something called bearings. A bearing is always an acute angle that makes a line or a path with the north-south line. So for example, if you have north 35 degrees east, that means from this north line, you're going towards the east 35 degrees. Okay, so that's the angle we're talking about. If you're doing south 70 degrees west, from the south, you're going towards the west 70 degrees. So that's that angle. If you have north 80 degrees, from the north, you're going to go 80 degrees towards the west. So that way. So this would be an 80-degree angle. And then south 30 degrees east. So you're going to go towards the east 30 degrees. So it looks something like that. Now, those are used for ships. For air navigation, bearings are always measured in degrees clockwise from the north. So you always start at the north, and then if we're going 110 degrees, you just go clockwise 110 degrees, like that. So 240 is from the north, and you go around 240 degrees. 50 degrees is from the north, clockwise 50 degrees. So that's what all of those look like. So we will use all of these in our word problems. The key on all of these word problems is drawing a good picture, so I'll be really careful. So we have a ship that's leaving port at noon, and it heads due west at 20 knots. So I am going to draw this on the coordinate plane, and we'll say that it's starting from the origin. Okay, so first we're going to go due west at 20 knots. So right there, that's good. Now, we don't know how far it went. To find that out, we're going to have to use its distance is rate times time. So it was traveling at 20 knots for 2 hours because it left at noon, and at 2 p.m. it changes distance, its direction. So this right here is 40 miles. Now, once it hits this point at 2 p.m., it changes course. So it's not heading due west, it's going north. So from the north, it's going 54 degrees to the west. So it looks like that. And let me draw that in there a little bit better. So from the north, we've got this 54-degree angle. Now it's on that heading for another hour until 3 p.m. So again, if we do another distance equals rate times time, it's going 20 knots for an hour. So this leg is 20. And what we are supposed to find is the ship's bearing and distance from point of departure at 3 p.m. So from where it started to where it ended. So let me just draw that in here. That's what we're trying to find, that distance. All right, so I actually need to make this a tiny bit smaller. The first thing you might notice is there are no right triangles in that, so that's not very helpful. So let me draw in some right triangles so we can see a little bit better. I'm going to drop this down and this over, okay? And then we'll call this one X and this one Y, and we are trying to find Z. That's our goal. Okay, and from that, we can also figure out this angle here. If that's 54 up there, that makes this angle, I think, 36. Okay, so now that we know that, 36, there it is. Let's see what we can do. We can find, if we can find Y and X, we can find Z. So take a look at this pink triangle that I've drawn. I know this angle, and I can figure out Y. Because the sine of 36 is going to be opposite over hypotenuse, so y over 20. And then I just need to multiply both sides by 20, make sure you're in degree mode, and y turns out to be 11.8. Okay. All right, so I can also find x a really similar way. I know that the cosine of x is going to be the adjacent over, sorry, not of x. The cosine of 36 is going to be the adjacent over the hypotenuse. So we'll multiply both sides by 20, and x is 16.8. No, 16.2, sorry. And then we can use the Pythagorean theorem to find z, because we know that 11.8 plus 16.2 squared is z squared. And so it turns out that z is 57.4 miles. So that was part of our answer. The other thing that we need to know is the bearing. Okay, so what angle it's going. So we need to figure out this angle here. I'm just going to call it theta. And we have lots of options here. I might use tangent. So the tangent of theta is going to be the opposite side, which is y. So that's going to be 11.8. And the adjacent side is x plus 40. So that's going to be 56.2. We'll take the inverse tangent of both sides and we get 12 degrees. Now that is not the answer, okay? 12 degrees is this angle, but remember ship bearings go from the north. So from the north, if this angle is 12 degrees, this angle is 78 degrees, and I just subtracted from 90. So its bearing is from the north, we have gone 78 degrees west. So its distance is 57.4 and its bearing is north 78 degrees west.